So if I start from mechanistic point of view, I think one of a very common problem is elimination versus substitution or different type of stereo involved in additions, right? So let me take how to decide elimination versus substitutions. Show me hands, thumbs up or something that is it okay for you for this topic? Elimination versus substitution is a common problem. How to decide? All of you know individually what is elimination. All of you know individually what is substitution. And here I'm talking particularly for nucleophilic substitution versus elimination. And the problem comes because the reagent that we are going to use will be, of course, base as well as nucleophile. And when something is acting as base as well as nucleophile, so then we have to decide that the answer should be substitution or elimination. Now, first thing you should see whether the reagent is sufficiently strong as a base, sufficiently strong as a nucleophile, then only the comparison will start. Like what I want to say is first, step number 1 that you have to follow is check reagent. Whatever reagent is given in the question, right? For example, if I am given I minus. Now, I minus is a very poor base, right? But it's certainly a good nucleophile. So here, wherever reaction if takes place will be related to a nucleophilic substitution reactions only, and we'll never observe that I minus will bring about any eliminations. Okay. Similarly, if something is a good base as a good nucleophile, then yes, we have ETONA. Now, ETONA can act as a good base. Yes. Can act as a good nucleophile. Yes. Both things this can exhibit. Now, how to decide? And is there usually a possibility that something is a good base but a bad nucleophile? Now, that usually is not possible. But yes, if something become extremely good as a base, then elimination will start dominating. Okay, that will say. The first step is what is the reagent that you will check. Step number 2 you will check is reactant, the organic reactant given. Okay. Now, whenever we are talking of a nucleophilic substitution versus elimination, normally we talk of alkyl halide. So second step is you take reactant and you compare. I mean, what is there to observe and compare? Whether it is 1 degree, it is 2 degree, it is 3 degree. Now, when I say compare the reactant, I also intend to communicate that also compare the alkene formed by elimination will be of what stability, and a reactant what type, and product stability. That is a very important factor. Product stability. Like there is a possibility something is say 2 degree only, but the elimination may result in aromaticity. For example, if I had this and I make any reagent attack, then there is a strong chance that elimination will dominate because aromaticity is about to come. So step number 2 that you have to check is what is the reactant, what degree of alkyl halide or what type of alcohol is the reactant, and then what product it will result in after the elimination. These two in combination will be the factor number 2 that will influence our elimination versus substitution products, right? Step number 3, you check heat, temperature, okay, whether this is given or not, because most of the time I can assure you that heat should be mentioned to carry out elimination. Okay, that is quite a basic requirement for a reaction in which elimination will dominate. And if heat is not given, then particularly for those reactions which are like borderline between elimination and substitutions, है ना, उनमें particularly for those under borderline reactions, Sn will dominate in absence of heat. And if heat not given, then nucleophilic substitution will dominate. Now let me tell you what I just said, how to have a comparative study of what we said as per our syllabus, as we decided nothing in particular, but chapter-wise observations, let me comprehend for you. For example, if I take alkyl halides, okay, if I take alkyl halides and you take very basic reaction, attack of water, then you take attack of aqueous NaOH, okay, then you take attack of alcoholic NaOH or KOH, whatever. These three in a sequence. Now see, water. First, when I talk of water, oxygen is a donor. Oxygen being a donor will be weak nucleophile. Electronegative donor, weak nucleophile. Right? I'm not mentioning any particular heat here, nothing. Otherwise, yes, there is a possibility that elimination by SN1 could have taken place. Okay. So if I take water, then I'll write here SN1 product ethers, alcohols. Okay. If heat given, then E1 will take place and alkene formed. Then answers will become alkene. Is that clear? Now see, because this water is a poor base as well as a poor nucleophile, so the mechanism first shifted entirely to unimolecular mechanism. Okay, that also is a part of your confusion, that SN1 or SN2. So my water is a poor nucleophile, poor base, so it is not going to be a bimolecular reaction. Now when I go to aqueous NaOH, what is my observation? Attacking species is OH minus. And when I say water, so OH minus, which is very good solvation, has taken place for this water, because aqueous layer will surround OH minus. Right, when this aqueous layer is surrounding this OH minus, so yes, it is a good nucleophile. It is a decent as compared to water. Nucleophilicity is increased. Yes, to certain extent, basicity is also increased, but not strong enough to abstract the alpha H from Rx. Okay, because the H is to be removed from carbon. Now, carbon is a very poor site to act as an acid. I mean, the H attached to carbon is not a good acid center. So, I will not expect it to behave as a easily removable hydrogen. Okay, so it is a good nucleophile. So, I'll say, okay, then I will take SN1, SN2, and for 1 degree and 2 degree Rx, we will form alcohols, of course, by SN2. But if it is a 3 degree Rx, now see, 3 degree alkyl halide is so good for elimination. Then also OH negative is carrying out substitution, forming alcohols, but the mechanism has been shifted from SN2 to SN1. Yes, here, if they intentionally give heat or something like that, then you may observe parallelly alkene by E1 reactions, unimolecular elimination reactions. There is a possibility. Okay, so that is a comparative set. Now, if I go to alcoholic QH, So still my attacking species is OH minus only. But alcohol being being a less polar protic than water, so I will say less solvation. So the alcohol is not surrounding OH minus to the extent water was doing. As a result, this OH minus is like a stripped off of its support system. Okay, its support system was water. It has been removed. So this OH minus is now acting as a, yes, can act as a good base as well as a nucleophile. That is a possibility. Okay, but its basic nature is improved, and usually we heat with that. What we do, alcoholic NH heat or something like that we put. So you observe E2 dominates, eliminations dominates. Okay, and when elimination dominates, alkenes are formed. Alkenes are formed. Is that clear? So this is how we are having one comparative set. Let me add more. Similar way. For example, next comparison, if I have ammonia and if I have NNH2, see the comparison. Ammonia and NNH2 both having nitrogen as a donor. Yes, as compared to water where oxygen was a donor, nitrogen being less electronegative will definitely become a better nucleophile. Right, as compared to water, this is a better nucleophile. So here when I was having SN1, ammonia being a better nucleophile, we primarily observe SN2, but not for all. SN2, I will say dominating for 1 degree and 2 degree alkyl halides. Okay. Now, I shouldn't say in general 2 degree always, because E2 for 2 degree and 3 degree alkyl halide. So as a result, what will happen as a result of this? If I have a 1 degree alkyl halide, then I will have amine as a major product. If I have a 3 degree alkyl halide, I will primarily have alkene as a product. Okay, as a major product, of course, we are not talking minors will be others. But if I have a 2 degree alkyl halide, then I will definitely have a mixture of amine plus alkene. It can give you both. Right? Now, in this 2 degree, if they further add heat, then you shift your answer towards alkene. If the product is becoming exceptionally stable alkene, you shift your answer towards alkene. Okay, that is how you will keep on switching your answers from one to another. Okay, there is no fixed rule that only this will be obtained as an answer or that will be obtained as an answer. It should always be fluctuating. If I take NNH2, now see, ammonia itself was much better as a base than water. And that is why this whole shifting to E2 happened. Right, shifting to E2 happened because ammonia was a better base, because in E2 you need a better base. If I take NNH2, NNH2 is a much better base, like alcoholic KOH, OH minus, right? Here it is NH2 minus. So water being a stronger acid than ammonia, OH minus is a weaker base than NH2 minus. So indirectly this is a better base. So in no condition it gives substitution. It always gives elimination. It always gives eliminations. Whether you talk of 1 degree, whether you talk of 2 degree, whatever you talk of, NNH2 will always give you elimination products. Is that absolutely clear? Right? Now let us move to similar set. See, alkyl halide is made to react with alcohols. And then Williamson reaction, RONA. Now, if they are made to react with alcohol, like water, you will have everything like water. that is SN1. Okay, when to form SN1, when to form SN2, same repeat will be observed. SN1 products will be, of course, there will be change. Products is बार क्या होंगे? Ethers. Product will found ethers. है ना? Heat given, then shift to E1, and alkene will be formed. Now again, when I say alkene will be formed, it entirely depends further on the stability of the alkene form. More stable the alkene, better the reaction will be. Is that absolutely clear? See how to handle alcohol versus RONA. If we are given RONA, RONA is a much stronger as a base. As compared to OH minus, it has become much stronger. So certainly the fear of elimination as compared to OH minus is now high. So if I take 1 degree alkyl halide, I can be assured that ethers formed by SN2. If I take 2 degree alkyl halide, now there is a problem. I will have both E2 and SN2, and at times E2 dominates. I cannot say that it is going to be a simple direct choice. It again depends on the condition of temperature and the alkyl halide. But if I take 3 degree alkyl halide, I am very assured that E2 dominates and alkene is formed. Okay, see the shift from alcohol to alkoxide. Right? If you have any doubt in between, please unmute yourself and ask. Okay, if there is anything you want to ask, please ask. If I say this alkyl halide is treated with Ki, now see Ki, as I said, it is a Finkelstein, this reaction is famous, a reaction of NaI acetone, Ki acetone. Finkelstein I'm talking. Never we think of alkene to be formed. We always take alkyl iodides are formed. It is a substitution reaction. We never consider alkene as a product. Why? Because that is not a possibility. I minus cannot cause elimination. Right? One more place, let me remind you where I minus failed to do elimination. Let me remind you. For example, if I put here ammonia. Okay, I take excess of this and I take ammonia. I will get R4N positive and say X minus. Usually, if I say this X is I minus, or whatever halogen. Now, none of the halogen is capable of causing elimination. So we treat it with Ag2O, we remove AgX and we change R4N plus OH minus. Do you remember which reaction I'm talking of? Now when I heat, I get elimination. Let me correct the spelling. Eliminations. Right? I'm talking of Hofmann exhaustive methylation followed by pyrolysis of quaternary ammonium salts. For that, you change from X minus to OH minus to carry out the eliminations. Otherwise, reaction will not take place. And yes, we get here Hofmann products. It is an E2 elimination. But you had to change it from I minus to OH minus because I minus can never cause such eliminations. Is that absolutely clear? When I talk of these alkyl halides. If I go to alcohols, let me go to alcohols. Now, if I talk of alcohols and say dehydration of alcohols, if I want to target. So if I take a primary alcohol, I'm quoting NCERT. If I take a very small CH3CH2OH. Now, what happens in SN1 and E1 comparisons? It is not about that what is the strength of a base or a nucleophile, because that is not the deciding factor. Deciding factor is carbocation stability and then the product stability as an alkene or a substitution product. So if you want to go for it, roughly we need 170 to 180 degrees centigrade and concentrated H2SO4, highly concentrated we need, then you get alkene. Okay, if you heat it with concentrated H2SO4 below about temperature, then you have ethers as a product which are formed by substitutions, right? Same way, of course, it is here, it is a comparison of SN1 and E1, and the entire thing is elimination to be carried out at higher temperatures, then only the reaction is taking place. Now, the point may come why we need high temperatures for elimination. See, delta G is equals to delta H minus T delta S. When I talk of elimination, definitely entropy is increasing. Some part is being removed and a new pi bond is formed. So this is being removed. So delta S is positive. If I talk of delta H, I am breaking the sigma. So the energy I am giving to the system is higher, and this alkene formed, energy released is less. So less energy is removed, is released, and more energy is given to the system. Is that exactly okay? So overall the reaction is endothermic, right? I am having a more expenditure of energy and the energy released is less. So the reaction is endothermic. Now the only factor to make this delta G overall negative is this temperature. To make this T delta is greater than delta H, thereby making delta G negative. So high temperature will make delta G negative. That is why for elimination, we always look for high temperatures. Even if the conditions, even if the reagents are there, but if the temperature is not suitably available, there is a chance that elimination may fail due to this whole thing. Okay. Now, if I take some 2-degree alcohol, yes, as the carbocation formed has become relatively more stable, and alkene will now be a little more hyperconjugative. So you may have a relatively lesser temperature than this, around 110 to 120 degrees centigrade. Same concentrated H2SO4 we take, then we have alkene. And at lower temperature than these, you will have still ethers. When you reach to very stable 3 degrees sides, then even around 90, rather I would say 70 to 90 की zone होती है. There is around, I'll write 80 to 90 degrees centigrade zone, you will have alkene, and the concentration of H2SO4 will also be less than what we took in the above. Okay. And at further lower, if I may say, and a lower temperature if I take, then yes, I may obtain ether. But as the branching has increased, the possibility of attacking on each other will also go on decreasing. Okay, so this is how the elimination and substitution comparative usually works. Now here, I would like to add you further that there are certain reagents like I minus with which we do not carry out any eliminations primarily. So what are those? Like if I take KCl, yes, I know that there is something about HSAB, hard and soft acid base concept, KNO2, and which says 3 degree may you take that and 2 degree may you take that, or don't take, go for NCRT please. Alkyl light plus KCl, cyanide will be attacking, whether this is 1 degree or 2 degree or 3 degree, you continue to form cyanide. Do not take elimination at any possible instance in this reaction. Here you continue to form isocyanide. No possibility of eliminations. Okay, KNO2, basically it is KONO. So you will have RONO, and in AgNO2 you will have RNO2. All of this go by nucleophilic substitution, and there is no elimination as they are not good base which can carry out such eliminations that we may need for. Is that okay? So this is how you plan elimination versus substitution. Now let me entertain few doubts, bacho, and have an open discussion. Yes, so one by one you can start. I saw Shrey. Yeah, Shrey, bolo beta.
For the
No, no,
alcohol in
Shrey,
the
wait, I cannot hear you. Wait, let me increase the volume. Yes, now you say.
ma'am, for alcohol in the presence of concentrated H2SO4, do they ask questions directly based on temperature? Because in the Narayana papers, I've seen only they either give heat or they don't give. They generally.
No, usually specific for that way. I can't say that they ask specifically with temperature, particularly in Narayana papers also. In J, just wait, let me add first what I was telling, then I'll come back here. Where is NCRT? Just wait. Aldehyde, alcohol phenol ethers. Yes, Girish, just wait, beta. Let me complete my issue with Shrey, then I'll come to you. I think that part is given in 11th NCRT. Yeah. Yes, Shrey, to as a specific in particular, I don't remember. They have asked particularly for temperature based questions, but you should know because there is a possibility that it could be there
Yeah, at the bottom
because
they've
it is
given
given in 11th NCRT.
they've given C2H5OH and H2SO4 443 Kelvin at the bottom.
But that is not something that it will affect your options based directly. Like in option, they have not given. Here you are seeing na this.
Yeah.
But this thing I wanted to say. Right? Is that clear?
You
I
don't
don't
need
know why.
concentrated H2SO4 for 3 days.
Can you be little louder, Shrey? I could really not hear you.
You don't need concentrated H2SO4 for the 3-degree alcohol. They've only given 20%.
So, in all, they have given only percentages of H3PO4. Here they have given H2SO4.
Sorry, H3PO4.
Why this volume is not getting up? I'll try more. Oh, no. No, now my worked. Just speak something now.
Yeah, so
Now it is clear.
does the acid matter?
So what were you talking? As I said, H2SO4, as in there, here na, they have said that you can use H2SO4 or H3PO4.
Yeah.
Right? So they have used this way. And but these are the questions at times. This type of thing could be asked. Okay, so just be aware. Yes, next question I was having from Girish. Where is Girish? Here is Girish. Yes, Girish.
Ma'am, why would no elimination happen in the KC and AGCN?
KC in elimination, whenever I'm talking elimination from the alkyl halide, what is the steps, right? So what is the steps? So you will say the steps is first of all, we have to remove that H. Is that correct? I have to remove that H from carbon attach H, right? If I have to remove, elimination means removing H which is with carbon, I need sufficiently strong base to carry out this. When I talk of CN minus, it can act both as a eliminating and a substituting reagent. If something is suitable for substitution, usually substitution will dominate. And plus, HCN is not a very strong acid. Yes, decent, but still much better as an acid as compared to hydrocarbon.
Yes, ma'am.
Right? So as compared to hydrocarbon, when it is acting as a base, as a good acid, its conjugate is not sufficiently strong as a base to initiate this H removal for bimolecular mechanisms. If it would have been a unimolecular mechanism, like I would have got a carbocation somehow and then this H to be removed, then yes, weaker acids can also abstract this H. Okay, and the driving force is already formed carbocation. But when I take HCN, I cannot take a condition where unimolecular mechanisms will dominate. Why? Because hydrolysis of cyanide will take place.
Yes, ma'am.
Right? So my conditions are bimolecular. I am not getting a carbocation. Cyanide being relatively weaker as an conjugate base to abstract hydrogen attached to carbon. That together adds up for this type of reaction. Plus one more thing, Girish, you might have observed that normally we do not observe heat on KCN arrows. Did you observe that? Right? So as to eliminate the option of elimination, even if it would have been minor possibility, particularly for 3 degrees.
Okay, ma'am. Yes, ma'am. Understand.
Okay. Okay. Anyone else regarding this? So, okay. So that was about elimination versus substitution. Now, the second point I want to go for a cumulative that I assume is important is a comparative reactions. Like what I mean by comparative reaction, I suddenly lost the file I was writing in, so I'll have to make a new file. I went here and there and I am not finding it. It doesn't matter. Let me use a new file for our work now. Okay, so new document. Yes. So what I wanted to take is a next thing is a comparative reaction. Now, when the syllabus is complete, comparative reactions, you should know there are few reactions where similar or confusing reagent combinations, and in one condition it cause one reaction, in other condition it cause another reaction. Let me exemplify and then you also add. Okay, whatever comes to my mind, whatever I have in my collection, I am adding. So first for that is, say, reagent chloroform and KOH. Now this reagent in different conditions, in different set of, what should I say, different starting material, different reactions you observe. For example, first, if this thing is given on acetone, then your answer will be, please write in your register parallelly whatever you find your answer, and then I will talk. If this reaction is given on phenol, then what will be your answer? If the same reagent is given on aniline, then what will be your answer? And I want one more thing. If it is given on pyrrole, same thing is given, same reagent, chloroform plus KOH. What will be your answers? Please give me. See, same reagent. How to modify your answers. So kindly start. Whosoever get an answer, please start. As I have only Shiva, Girish and Shrey. 3 names are only by names are appearing on my screen. There may be more. Kaushik is also there. Mihir is also there. Anish, Rishabh, Sanjay. Whosoever wants to add answer, please add. Whichever, A, B, C, D. Hannah, and I think all of you are already allowed to unmute, so I don't have to give you opportunity every time. Sanjay, yes, Sanjay, bolo bachche.
Nothing, ma'am.
Ayo, I thought you are giving me some answer. Okay, Mihir, would you like to add some answer? Any out of 4?
First one is haloform reaction. Like this thing,
Haloform reaction with chloroform and KOH beta?
1 minute.
Okay. Always use writing. Register is a must for organic. Everyone, huh? No, I expect all of you are there with your register and pen and writing whatever I'm asking. Do it like mathematics. Proper solving is required. Mechanism, assumptions, whatever you feel like you write. Rishabh, would you like to add?
And which one?
Anyone, any out of 4, whichever you got, you read.
Excuse me,
Anyone.
ma'am. I think I got answer for like B and D.
Okay, add.
This one will be Reimer Teeman, ma'am. Second one will be.
B is Reamer Timan, and so your major product, Sanjay, is this.
Ma'am, yes, ma'am. Ma'am,
What
I
is
have
the
a doubt, ma'am. Since we have been taught that since we are using KOH and not NaOH, para will be the major product, ma'am.
Yes, that is also true. So I rather give it NaOH only. You are taught correct. So this
So
is.
here means ortho will be the major product.
So what is the name?
Salicylaldehyde.
Anna? Aldehyde. Okay, what is
The
you said
D
D
also
also.
is the same thing, ma'am, since it is aromatic.
So what is the product?
In NaOH means in the ortho position, like ortho alpha to nitrogen, the aza nitrogen.
Okay. Is that the major product, guys? Anyone else want to enter? I think the major product for this is this. Abnormal rheumatism. The major product is this. This one is abnormal rheumatism. Is that correct? Anyone? I don't hear from anyone. Okay. So who wants to add for this? Acetone. Anyone wants to add for acetone? Please do.
Ma'am, I have an answer for A.
A. Okay, tell.
Ma'am, since the alpha hydrogen will be abstracted and the CCl2 will be acting as carbene and will be a good electrophile and will be able to attack there.
What happens here? First, you have CCl3 minus. As you are saying, acidic H. This is acidic H. And this is now a nucleophile. Yes, it can lose and form a carbene. Right?
Yes.
But will the reaction, this is CCl3, huh? I think overwriting CCl3 minus. But as this nucleophile once formed, will this reactant wait to form carbene or anything? Why not direct attack? See, with respect to molecule, they will not wait. Chlorine
No,
2,
because I thought like acid-base reactions are much faster.
acid base
So,
took, acid base took, but the site of acidity is different.
okay, ma'am.
In fact, first step is still acid base, what you thought. But identify stronger acid site is chloroform acidic H. Okay. Is that clear? See, one reagent causing nucleophilic attack. When this CCl3 minus fails to attack, when we go to this, ring is electron dense. So CCl3 minus cannot attack, na? Therefore, it was carbene formation. And then carbene comes into scene. Is that clear? Here it was nucleophilic addition reaction, AN reaction you observed. What about this? Aniline and chloroform and NH. What will I observe?
Isocyanate.
And someone said, please repeat. Who was that?
Isocyanate.
Can you please help me with the name of the reaction? It is a very famous reaction.
Carbylamine.
Yes, yes. And Girish, one more thing. Sanjay just asked me that here NaOH or KOH was there. I avoided the discussion, but do you think what he was saying is correct for rheumatoid? I think it was for some other reaction. Do you remember what he's saying?
I don't know.
Ma'am, I thought of the Kolb's reaction, but
But it is not here, na?
no.
Yes. It was in Gatterman it was in Kolbe's reaction where CO2 attacks.
Ma'am, but I had clarified a doubt with our teacher regarding whether it's same thing occurs in Reimertimen, and he also said yes for it.
Well, I can't help with that, but it is in CO2. Okay. So
Okay.
isocyanide is formed, and as I think I got correct name also, this is a very important reaction, carbyl amine reaction, or also known as isocyanide test for primary amines. It is only for primary amines, right? So this is one set where same reagent giving you 4 different set of reactions. I hope all of you have now remembered what I am talking of. Okay, let us move to next set of similar reagent where different type of reactions you can observe. Reagent number 2 I am taking is, say, diazomethane and triple bond N positive. This is called diazomethane, right? I'll tell you the chapter, or rather I'll tell you the reactant. If I have RCH double bond CHR, of course, reagent is diazomethane. One heat is not given and one heat is given. What will be the products? Tell me. It reacts with alkenes. Then it reacts with alcohols. Then it reacts with phenol. Then it reacts with this aldehyde ketone, RCHO, and then with ketone, RCOR. It reacts with carboxylic acids. Same reagent, है ना? It reacts with acid chloride. Come on, help me comprehend same reagent, what all reactions could be there. Anyone can chip in, nothing like that any particular I call for. जिसको जो reaction याद है, whosoever sudden, have a memory of any of the reaction, join us. I hope at least one reaction to one person also if there, then I can continue. Yes, this was this, this was this. So what was what? Anish, would you like to say something about any reagent?
Ma'am, can you give some time?
Okay. I'll wait. Whenever you are ready, just let me know. I'll wait for your response.
Ma'am, for alcohols, it will produce ethers, ma'am.
Yes, and I should add some strong Lewis acid to add.
Yes,
Then
ma'am.
it will be ethers. I got first answer with alcohols. If I add some Lewis acid heat, I can get methyl ethers. I have only one hand, Sanjay. Okay, Sanjay, tell one answer. You were saying about alkene, I guess.
Yes, ma'am. With heat, I think it will form like cyclopropyl alkyl ring.
Like this.
Yes.
Right? With heat, this forms carbene. Methylene. That is how we are having this. Without heat, it was diazomethane is a resonating structure, na? So it can act as a dipolar ion also. Like ozone, it can have addition, and you can have a 5-member ring formation like this. Okay, that was with and without heat. Okay, with phenol, what is your opinion as it has become more acidic? So no need to have this Lewis acid help. You can directly have methyl ethers formed. Let's move to rest. Now again acidic edge in acid. So you will again have methyl ester form. In all of these reactions, like for carboxylic acid, if I say what is happening, RCOOH plus CH2 minus N2 plus, this is having RCOO minus plus CH3N2 plus. Now N2 is a very good leaving group. So now it takes substitution. And you have RCOOMe formed, ester formation, ether formation. These three reactions are like this. Okay. So it can act both as a, see, base here and nucleophile also. All behaviors you will observe. Okay, coming to other three left, D, E, and G. What will be the reaction? With D, what can I expect?
Ma'am, can I say, is it possible?
Yes.
Epoxide, ma'am.
Epoxide is like one of the products like this.
Yes, that not for aldehydes. I think it's for yeah, for aldehydes. Yeah.
For both. For both
Yeah.
aldehyde and ketone, we can have epoxide as one of the products. Now, what is happening? When I say one of the products, it is like this. I have to write the mechanism. I'll write. So when I have aldehyde and I have diisomethane, CH2 minus N2 plus, reaction starts with nucleophilic attack. So RCHO minus CH2 N2 plus is happening. Now there are two methods, right? One by white pen you can see is RCHCH2O. One by yellow I am writing that this is going is same, okay, and hydrogen is shifting. Then you can also have methyl ketones to be formed. So one more product you add here, that this plus just one carbon added but methyl ketones. Whereas if it is ketone, and if I do the same exercise for ketone, RCOR dash plus CH2 minus N2 plus, then I started the same R dash O minus CH2 N2 plus, same way N2 goes O minus attack, so RC R dash CH2O1 is epoxide. And the other possibility that when N2 goes, whichever's migratory aptitude is better. So you have a one step increased ketone. So you have a ketone, but one carbon is increased. Now that depends on migratory aptitude who will move. Okay, whosoever have a higher migratory aptitude will be the one shifting. Coming to RCOCl, if you remember, it is a part of very famous name reaction called earned start reaction. So first this attacks and you have RCOCH N2 plus minus. This is formed and this is called alpha diazo ketone. When this now leaves and you heat alpha diazoketone on Ag2O, you get RCH double bond C double bond O. When you do hydrolysis, you have a one step up carboxylic acid, right? So here it is earned start reaction. So again, you have seen the same reagent and doing different type of reactions for different starting material. Is that clear how this reaction happened? Tell, is this fine? Okay. I hope all of you have these reactions already in your notes. Just go through them. If you have any more doubts, ask me. Right? If you find anything more, you can ask me then. Okay. So this type of, yes, I think Sanjay hand raised before only, na? Nothing for doubt now. It was before. Okay. Yeah. So anyone has any other doubt? No? Now, similarly, there could be many more. If tomorrow we'll get class, we'll have 2, 3 more such reagents which have multiple, reaction effects, right? And then from Monday, we'll start sequential, complete revision of organic, daily 1 hour from basics to, like I will go fast for basics, and wherever you want me to stop and you want to write, we can hold.